For this question, we have to find the derivative of a secant function. Remember what the derivative of secant is. The derivative of secant is secant times tangent. So we'll keep that in mind. The value of k here is a constant, so don't get confused by that. And when you look at this, you should really see this as a product. We have one factor here, the x, and the other factor is the secant of kx. We could put brackets around here, but it's not necessary. So let's see how this goes. So this is a product, so we are going to be using product rule. The derivative of the first factor, x, is 1, multiplied by the second factor left alone, plus the first factor left alone, multiplied by the derivative of this factor here, secant kx. Now, this might be a little bit weird, but remember the derivative of secant x, why don't I just write it quickly over here? The derivative of secant x is secant x tan x. So we're going to use the chain rule right now to do the derivative of this because we have to kind of ignore the kx. So the derivative of secant kx would be secant kx tan kx. Maybe I'll put brackets there just so it looks a little bit better. And then by the chain rule, I have to multiply by the derivative of kx. And what's the derivative of kx? Well, it's just k, right? So that's the hard part right there in this question. I hope that's okay. Now let's see if we can just write it a little bit nicer. We don't need these brackets here. We can just write secant kx. And here, why don't I bring the k to the front? So we'd have kx, secant kx, tan kx. And we could leave it like that. That's good. It is tempting, though, to factor the secant kx to the front. Why don't we do that just to see how it looks? So it would be a 1 plus kx tan kx. And that's a good answer as well.